All right, for this lesson, you will learn how to solve systems of quadratic and linear equations. So for example, if you have a parabola, okay, and a line in the Cartesian plane, they could intersect at 2 points, which means if there's an intersection of 2 points, then that tells you that this system has 2 solutions. Okay, so this is when you have a line and a parabola intersecting each other. It's also possible that they might have just one intersection. So in this case, you have one solution, but don't forget, if there's only one solution, since it's a quadratic, it's gotta have 2 of them. So then that means it's gonna be a double, and you can see it graphically. You can see that the graph, the point is right on the only one point, and it's gonna bounce off of that line. Okay. It's also possible. This is a slope of 0 for the line. This is a positive slope. And for this line here, it's possible that the line and the parabola could intersect at only 1 point. And again, that will be, anyways, that's just one solution. So this is system, so don't worry about what I said here. It's not a double, because this is just a line with a slope of 0. And this is not a slope of 0, but they only intersect at 1 point. Okay. So this is systems, which is different. What if we have 2 quadratics? Okay, well, let me just give you one more line. It's also possible that in the system, the graphs will not intersect at all. So in this case, we say no solution. Okay. And then the next part is, what if you have 2 parabolas intersecting each other at 2 places or 2 different points? So then for this one, we say that this one has 2 solutions. So this system has 2 solutions. So graphically, we see the intersection at 2 different points. All right, so for this part, it says solve using substitution. So what I am going to do is, I see that y is isolated on this side, right? So you have y equals x plus 6. So I'm going to go to the first equation and replace that y with x plus 6, which is what substitution means. So then I'm going to take this equation and replace or substitute for y with an x plus 6. And that equals negative x squared plus 5x plus 6. I'm going to bring everything to this side. Okay, so meaning I'm going to jump everything, the 3 terms, to the other side. So they are all going to change signs. So then I have negative x squared. That 5x becomes minus 5x. And then that 6 becomes minus 6. And then we have the x here is positive, so plus x plus 6. And now we have a 0 on this side. Okay. Then we combine like terms. And this x should have been negative because I jumped it. It was negative, now it becomes positive. So then I have negative 5x and positive x. They combine to negative 4x, and negative 6 and positive 6 cancel out. So this is all we have left for that equation. So then there's a GCF here. The GCF is x. We can factor it out. And then x equals 0 is one equation, and x minus 4 equals 0 is the other. So for this one point of intersection is 0, 0. And for the other, we add the 4, which means x equals 4. So 4, 0. So these are the 2 points of intersection of the x-axis. Okay. All right, next example. So I'm going to do the same thing here. I have y by itself on one of the equations, so I'm going to substitute with this y with negative 2x plus 5 equals x squared minus x plus 3. So I'm going to do the same thing I did here, but I'm going to have the x squared on this side because I don't want to have it negative. Okay, so I'm adding 2x to both sides of the equation. I'm subtracting the 5. And then this becomes 0 equals x squared. Negative x plus 2x is 1x. And 3 minus 5, that's a negative 2. So from here, we need to factor this one out. So find multiples of negative 2 that when we add them, give us a positive 1. Do they exist? Think about this. Do those multiples exist? I'm sorry you couldn't see that. Do those multiples exist? And they do. So multiples of negative 2 that add to 1 are x minus 2 times x plus 1, right? No, there's x plus 2, and this should be minus 1. So we get a positive 1 when we add them. So then x plus 2 equals 0, and x minus 1 equals 0. So then x equals negative 2, and this one is x equals 1. So I'm going to go back and correct myself on the previous example, because we're trying to find the system, we're trying to find the points at which the graphs intersect. Okay, so this is going to be a little bit different, meaning I need to go back to the equation and plug in for x. So this is x equals 4. So I'm going to go to either one of them. The easiest one to go to is the second equation to find a y coordinate. So y equals, the first one is 0. So instead of x, 0 plus 6, which means y equals 6. So then one point of intersection is where x is 0 and y is 6. And the other is y equals 4 instead of x. Okay, so 4 plus 6, which is 10. So then the other point of intersection is where x is 4 and y is 10. So there we have the solutions to this system of equations. So let's do the same thing with this problem here. Okay, so I'm going to go to the second equation, y equals negative 2 instead of x. X is equal to negative 2. So negative 2 and then plus 5. So then y equals 4 plus 5, which means y equals 9. So then one point of intersection is where x is negative 2, one solution to the system, and y is 9. That's one solution, okay? And then the other, y equals, the other x value is 1, so negative 2 times 1 plus 5. So y equals negative 2 plus 5, which is 3. So then the other point of intersection is where x is 1 and y is positive 3. So there we have the two solutions to this system of equations. All right, so let's move on to the next example. Again, notice the y is by itself. So I'm going to substitute for y on the first equation. Negative x squared plus 5 is equal to x squared plus 4x plus 5. So then I'm adding x squared here, subtracting 5, plus x squared here, and subtract 5. So then here we have a 0 equals 2x squared, and then plus 4x, and the 5's cancel. So then there's a GCF of 2x, so then this becomes x plus 2. Okay, now set each term equal to 0. 2x equals 0, and the other is x plus 2 equals 0. And then we solve. So divide by 2, which means x equals 0, and subtract 2, which means x equals negative 2. Okay, so now let's find the y coordinates. So I'm going to go to this equation again and find the y values. So y equals negative 0 squared plus 5, which means y equals 5. So then one point of intersection is 0, 5. So these two graphs are going to intersect at this point. And the other, y equals, I have a negative 2, but notice we have a negative in front of it. So negative 2 squared plus 5. So then I know the 4 becomes positive, but this negative makes a negative. So negative 4 plus 5. So then y equals 1. So the other point is where x is negative 2 and y is positive 1. So we can expect these two parabolas to intersect at these 2 points. All right, let's go on to the last example. For this one, I'm going to substitute here. So I'm going to plug in for y on the first equation. So then I have 9x plus 6 equals negative 3x squared minus 3x minus 6. So then I'm subtracting 9x and also the 6, so minus 9x and minus 6. So everything cancels here. We have 0 equals negative 3x squared minus 12x minus 12. Then there's a GCF of negative 3. So I'm going to factor it out. So negative 3 times x squared. This becomes positive 4x, and this becomes positive 4. Okay, then I'm going to divide by negative 3. So then 0 equals x squared plus 4x plus 4. So notice this is a perfect square trinomial, right? So then multiples of 4 that add to 4 are 2 and 2. So then 0 equals x plus 2, that's 1, and the other is also x plus 2. And you can always check this. If you multiply here, you use FOIL, you should be able to get this back. So then 0 equals x plus 2, then subtract 2, which means negative 2 equals x, or x equals negative 2 mean the same thing, okay? So since we know we have two of them, then this tells you, well, we know the x value. Let's find the y value. So I'm going to go to this equation here and find the y value, or y coordinate. So y equals 9 times negative 2 plus 6. So then 9 times negative 2 is negative 18, and negative 18 plus 6 is negative 12. So then there's only one point of intersection, and that is where x is negative 2 and y is negative 12. Okay, and we are done with this lesson. Well, thank you for watching. Bye-bye.